Okay, hi everybody. Welcome back to section 6.1. And in this video, we're going to get started on how we can start playing around with some power series. And in this video, we're going to see, how we would handle, maybe multiplying two power series together. And there's other operations you can do like addition, which we'll see, in division. But yeah, it takes a lot of playing around required to be able to combine them and solve differential equations. So let's go ahead and try out the first one. Like we want to find a power series representation, meaning like one sort of setup for e to the x times sine of x. So, let's kind of recall that e to the x, the power series representation for that, the Maclaurin series, is, n equals 0 to infinity, 1 over n factorial, x to the n. And then the first couple terms of that are 1 plus x over 1 factorial plus x squared over 2 factorial plus x cubed over 3 factorial, etc., etc. And sine of x is the series starting out at n equals 0, negative 1 to the n, all over 2 to the n plus 1 factorial times x to the 2n plus 1. Okay, and then the first couple terms of that are going to be x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial, etc. and etc. Okay, so we want to, you know, use these facts together and, maybe we could say something about the interval of convergence. They're both infinity to infinity. Okay, but let's go ahead and start having fun with this. We want to find a power series representation of these. So what we want to do is multiply them. So this would be e to the x times sine of x. And well, what is e to the x? We kind of just wrote down a couple terms of those. So this would be 1 plus x squared over 2 plus x cubed over 6. And let's do one more term. We would have x to the 4th over 4 factorial, which is 24, dot, 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 times sine, which would be x minus x cubed over 6 plus x to the 5th over 120, dot minus dot, dot, dot. Okay, so what we want to do is multiply this out. We want to FOIL this out. So these are infinite power series, so we're never going to get all of the terms, but we can at least get a couple going to get an idea of what this might look like. So let's go ahead and start foiling this out. Like, you know, it would be 1 times x times that, and et cetera, et cetera. So I'm not going to do all of them, but maybe pause the video really quick and see if you can FOIL this out. Okay, so if you tried it out, this is a long list of terms you would have gotten if you FOILed out all the terms that are on screen right now. Once again, this is infinite series, so you could have done more, but I think this is a good stopping point. And then we even get up to some obnoxious calculations like x to the ninth, 2,880. Yeah, we can maybe even shrink this a bit. That's a bit too big of a number. Um, Kind of get the point a bit. So maybe we'll cut out maybe like a x to the fifth, because we don't want to write all these out. It's a little unnecessary. So to clean this up and to kind of get a general power series, one thing we want to do is group the powers. Okay, so I'm going to group x, the x squares, the x cubes, the x to the fourth, x to the fifth. And so what that would be is there's only one x and there's only one x squared. It's, right here. So we don't have to really group those with any other terms, but there's a couple x cubed. So there's one right here. There's one right here. So we're going to group those together. So that would be plus negative 1/6 plus 1/2 x cubed plus, I'm going to group together the x to the fourth. So there's one right here, negative 1/6. And then there's one over here, positive 1/6. And then I believe that's it. Yeah, and we're not coming back down. So what I would have is negative 1/6 plus 1/6 x to the fourth. And then let's move on to the x to the fifth. I think that's where we'll stop. Otherwise, the numbers get a little too obnoxious. We have 120 or 1 over 20, 1 over 120. We have negative 112 and then 1 over 24. And then that's it. So we'll have 1 over 120 minus 112 plus 1 over 24 x to the fifth plus dot dot dot. Okay, so we can combine these constants. We can even see that this x to the fourth term cancels out, goes to 0. So what we're left with essentially is x plus x squared plus x cubed over 3, because negative 1/6 plus 1/2 is 1/3. And then the x fifth constants go to 1 over 30. So this is x to the fifth over 30. Okay, so that is essentially our power series representation. We can keep going and going forever, but I think these four terms are good enough. And so that's the power series representation. We also want to communicate what the interval of convergence might be. But that's a look, we can reason what that might be. So since the power series e to the x and sine of x both converge on negative infinity to infinity, then this product series also converges on negative infinity to infinity. So, the interval of convergence is also negative infinity to infinity. So let me circle that, and then let me circle that. Okay, so this is us playing around a little bit with some Maclaurin's power series using multiplication. We're going to see what addition might look like. That one's a little more involved. But thank you for watching, and I'll see you in the next video. Take care.